would say plus 2q and another is plus q. Then again, the number same here. If I assume 16 lines, then here 8 lines of force should come. And the lines of force, I'm showing it in this way. Got the idea? Okay, one more small, very important information. Let me share it. Then I'll come back to this one. If two positive point charges are there in a region, this is a 1. Let me take this is 2. In all the cases, we'll try to see what happens to the field. Next case. Plus 2q charge plus q charge. Similarly, plus 2q charge let me draw a little bit below. This is very fundamental thing which a student must know. Plus 2q charge minus q charge. Now, what is the use of this? Let me use some other color pen. No. So the total separation between them. So let this be A. I think not visible, very thin, the nib has become. I'll change it. Yeah, this will be okay. The separation is A. So first, what is the field at this point 1? So due to E1 will be like this. Due to this point charge, due to this point charge, E2 will be like this. So what are E1, E2 equal to? They're of equal magnitude. So therefore, what is the net field at point P will be 0. The net field at point P will be equal to 0. This is in the first case. So two like point charges are there. Exact at the midpoint, what is the resultant field? Will be 0. Then if I bring two unlike charges, this is 1, this is 2. The field here will be E1. And what about the due to negative charge will also be directed in the same direction. So what is the E1, E2 equal to KQ by A square. So the resultant field at point P at the midpoint will be equal to how much? KQ by A square only. It will be non-zero. So what is the total field? E1 plus E2, which will be 2KQ by A square. Now, what about the field? Now, what about the field here? Okay, no, I want between these 2 point charges. Will field will be 0? What is the condition now? This having a magnitude 2q, this is q. So field will be 0. So the distance of separation between them is how much? 2a. Let me pick up a point at a distance x. So what is the resultant field here? E1, this is a point 1, and here it will be E2. So the resultant field at this point will be E1 minus E2. What is E1? K2q by 2a minus x whole square. What about E2? Kq by x square. So I want the point where the field will be 0, the position. So there should be equal to 0 is equal to 2kq by 2a minus x whole square. Kq by x square. So kq gets cancels. So 2x square. Let me solve it. So 2x square is equal to 2a minus x whole square. Two x square, 4a square plus 2x square minus 4ax. This 2x square get cancels. I'll get expression for x. So what is x is equal to? Okay, come here, no? So we were here, no? So what is the field strength at exactly the point where it will be 0? So I do have 2 charges. So one is of magnitude 2q. The other is of magnitude q. What is the separation between them is equal to 2a. Okay, let me proceed in this way. There's a point P. So the field strength that due to point charge 2q, it will be E1 towards right. Due to point charge plus q, E2 it will be towards left. So the resultant field at point P should be the difference of that. So E1 is equal to K2q by 2a minus x square. Then due to E2 will be due to point charge plus q will be KQ by x square. So I want a point where the resultant field will be 0. Getting this one? There's a condition. Okay, then EP is equal to 0. Let me substitute and I'll solve for x. I'll expand this, I'll get a quadratic equation. So what is the position? The position what I get is like between the point charges at a distance of √5 minus 1a, means from this point charge to at a distance of √5 minus 1a, the field strength will be 0, that one, not at the midpoint. For 2 identical point charges exactly at the midpoint, the field strength will be 0. If 2q and plus q, the field strength will be 0 at the midpoint. I think that there's a very important conditions here. When we discuss some problems, no, we need this particular background. What about field anywhere here? Will it be 0? Due to positive point charge plus q, it will be like this. Due to 2q, it will be in this direction. Not possible, no? What about here? Due to 2q, I'll come to this one. Due to plus q, it will be in this direction. Due to 2q also, it will be in the same direction. So the field cannot be 0 at these points. The net field can be 0 only in between them. And what about for this? You can search it. If you take plus 2q and minus q, no, the field can be 0 at a point other than in between point charges. Here I took plus 2 and q. So one charge is of magnitude plus 2q, other is plus q, where the field will be 0 at the in between line joining the point charges, the field will be 0. So here, what is the condition now? Net field will be 0 in between line joining the point charges. Only the field can be 0 here. If you take plus 2q minus q, check it, will not be in between, will be external, that one. Okay, we'll explore that condition also. Let me explore that also. So if it is plus 2q, minus q. So what is the separation between them? So where the field will be 0. So I'll call this as 1. This is 2. The field here will be E1. E2 will be like this. So let it be at a distance x. Then the resultant field EP is equal to E1 minus E2. This should be 0. What is E1? E1 will be K 2Q 2A plus X whole square. What about E2? E2 will be KQ by X square. Again, the same mathematics here. So this will be KQ get cancelled. So X square 2x square equal to 2ax whole square. Solving this one, 2x square equal to 4x a square plus x square 4ax. X square minus 4x minus 4a square equal to 0. Okay, now we'll solve this one. This will become quadratic equation for x equal to 4a plus or minus 16a square plus 16a square by 2a. 4a plus, this will be 16, this will be 4a root 2 by 2. 16 plus 16, 32, 32 will be 16 into 2, so we'll get it. So this will be now, a will come outside. For a, if I take common, so 2a will come. So 1 plus or minus root 2. Okay, these are the values. So 2a, 1 plus root 2 is one value, x equal to 2a, 1 minus root 2. What about this 2a 1 plus root 2? Okay, root 2 is 1.41. Somewhere else it's possible. X negative 2a minus of root 2. Root 2 is 1.41. So 0 0.4, 0 0.8 x will be. I think this is not possible, no? I'll take it out this one. So where the field will be 0 at a distance of 2a 1 plus root 2 from point charge q, because the x is what I measured from here, x equals 0. Measure from point charge 2. Like this, a student has to really analyze where the field will be 0 when identical point charges or different point charges when they are kept it. And then we'll explore the next one, how to express the how to find out the electric field strength in vector form. Can we find out the electric field strength in the vector form? So I kept a point charge plus Q in a space. It is, and what is the position vector of the point charge? Let it be RA bar. Then I want to find out at point B the electric field strength due to this point charge. And what is the position vector of point B? Will be RB. This will be the position vector of the point charge RB. That one. This is the position vector of RB. So this will be RB. This will be RA. So what is the condition? A point charge Q is kept at a point A, then at point B, the electric field strength due to that point charge has to be determined. Okay, what is the basic our idea? Due to point charge, what is the electric field strength? Equal to KQ by R square. So now what is the direction of E bar? The direction of E bar will be R bar. And what is R cap? Unit vector directed along the R bar. So here we'll write the vector form. RA bar plus R bar should be equal to minus of RB bar. So finally, what is R bar is equal to RB bar minus RA bar. Then KQ, this will be. So now what is the, how you define the electric field strength in the vector form? This part will be magnitude into unit vector R cap. What is R cap? Further, we'll write it as R bar by R. R bar by R. Now, KQ by RQ by R. This part is very important. So what is R bar? RB bar minus RA bar. What is R? Mod of RB minus RA whole square. So this will be the vector form of electric field due to a point charge. If a point charge Q is kept in a space with a position vector RA bar, then at position vector RB bar, what is the electric field strength given by this particular formula? Okay, this is about the overall due to point charges, the field, all everything. So I'll have one more condition. If I have 4 point charges numbered like this, how to calculate the resultant force acting on? They're kept at the corners of a square. The point charges where they're kept at the corners of a square here. So how to find out the resultant force acting on individual point charge? Let this be 1, 2, 3, and 4. F12, because they are like charges. F41, F14. Then 1 and 3 will also interact. This will be F13. Similarly here, F23, F42, F34, F43, F32, then F42, F31. Now what can be this angle? 45 degrees. What can be this angle? 45 degrees, because along the diagonals, these forces, this force F13, F31 should act along the diagonal. Similarly, F42 and F42, F24, no, it is, should act along the diagonal. So now we'll write the magnitude, then I'll take the vector sum of all these forces. I'll get the resultant force acting on 1, similarly on 2, similarly on 3, on 4. What